Let's help Arnie prove his case here. We're going to do a null hypothesis test. So that means we have the 5-step process. First thing is we need to find a test statistic information. So there's the population mean. There's a sample mean that Arnie did. There's the population standard deviation, and we need the sample size. There it is. There's the data. So let's go to town. First thing we do is state the null hypothesis. And they're just stating that the mean weight is in fact 1.672. Now the alternative hypothesis, and this is what Arnie is trying to prove, is that no, it's not 1.672. You notice these two look exactly alike except for the symbol between the mu and the number. So what Arnie is stating that it is less than. So let's go ahead and find a test statistic. Break out your formula. Plug and chug. You're going to get a negative 1.72 as a z-score. Let's double check that in Excel. In Excel, pick a cell, any cell, go to the function bar. You're going to go to, make sure you're in statistical, you're going to go down to standardize. And it's going to do all this work for us. So the x in this one is the sample mean. And then the mean is the population mean, the stated mean. And the standard deviation, you got to be careful here. You got to divide it by the square root of the sample size. So it's roughly 7.1. Click OK. And we have a confirmation. So let's find out what the area is generated by that z-score. Let's look it up on the table. Here's your 1.7 row, and there's your 0.202 column. So it looks like 0.0427. Let's double check this in Excel. Pick a cell, any cell, go to the function bar. Make sure you're in statistical. To get a z area, you're going to use the norms dist, the one with the s in the middle. Norms dist. Ours is negative 1.72. Click OK. And we do have confirmation. All right, let's see if this is significant at the 5% level. The 0.05 is the alpha, that's the cutoff level. And in this case, our critical value is greater than our calculated value. So that is good news. When that is the case, you call the data significant. It's significant enough so you can reject the null. What you're really saying is that it did not fall within the calculated confidence interval. If the null were true, then we should only get these results about 4 times out of 100, yet here you did, we got it on the very first try. So we would reject the null at the 5% level. Let's check the 1% significance level. Now the critical value is much smaller than the calculated value. So when that's the case, you do not have strong enough evidence to reject the null. So you cannot reject the null in this case. That's it. MGZ out.